Now, we are in the grain fill period right now, right? And so you are setting up, in the early part of the season, you're setting up that crop for success during right now. And this is perfect weather, right? It's 70s, right? Cool nighttime temperatures. And it's been amazing. I really feel that we have a very high, we have an opportunity to at least get close to that 90 bushel average that we saw last year. Now, what we're looking at here is as we move from east to west across this trial, we've got 3 different nitrogen rates out here. We've got a relatively high rate. I know some of you are pushing higher than that, but we've got a 120-pound rate out here, right? And so it's kind of a low spot in the field right here. But what you're seeing in these higher nitrogen rates, of course, you're going to see more biomass, right? And you're also potentially going to see differences in the quality of that grain. So our first goal here is to identify those varieties that are going to produce more, same yield with less nitrogen, right? Which means less investment on your part. So we're really focused on profitability here. Now, this is my opportunity to let you all know you are part of that value chain, and the management decisions that you all make on your farms today, well, that you have made, and that you're going to make now, and that you're going to make at harvest, are going to directly affect the marketability of that grain downstream, right? Whether or not you're going to be able to sell that for the maximum dollar value is dependent on whether the milling industry can use that grain to create the products that consumers demand. And I use that word demand, right? Consumers want a very consistent product that's going to match what they bought before, right? And so I'm really proud of working in Michigan wheat because 95% of the grain produced in this state, 9 out of 10 bushels, are going to be consumed by folks at the supermarket, right? The entire middle of the supermarket, all your Wheaties, all your crackers, right? Those are coming from companies that are buying flour lots, specialty flour lots from our milling industry, right? So everything that you do on your farm is affecting the quality and the marketability of that crop. So it's important that we are able to consistently deliver that crop. So when we start changing nitrogen rates, what does that affect directly, right? What part of the grain is that going to be affecting directly, right? It's going to be, well, nitrogen, every protein molecule, every amino acid has nitrogen on it, right? So if you change the protein in there, you can change the functionality of it, right? Something that's supposed to be an ideal, let's say an ideal cracker wheat, nice crispy, strong lactic acid profile, strong gluten, right? That could change, right? You're not going to get the crispiness to those crackers. It's going to be more like a cake flour, right? Very drastically different types of quality parameters there. Now, when you change nitrogen, you can change those. But I bring that up just to let you know that we're so connected directly to those consumers, and so having consistency across the value chain is very critical. Now, so we've got a specific variety highlighted here. So this is an older MSU release, whitetail here. It's been on a few acres in the thumb here. But you can see under 120 pounds of N, this isn't the highest rate I know that folks can use here. You're going to manage for whatever your yield goals are, right? You know your farm well enough to do that. But you can see we have a lot more biomass here. And so, and actually we're going to start here and move down that way. But you can tell the difference. So I want you to just sort of get an idea of how that crop is going to change from these different nitrogen rates, right? I can pick out Jupiter a mile away here too. So we've still got very good green flag leaves, the ones that don't have barley yellow dwarf, of course, right? So you can see that this is going to change as we move from our 120-pound rates. We're going to just migrate further south, or excuse me, to the west here, folks. Again, mind the tire tracks. This is indicative of the wet spring that we had, and we surely did see in our research a benefit from a split application. Now, in contrast, this was all applied as urea right at green up. So this was all applied in one shot versus variety trial that we're going to. That was a split application. We went 60-60 with a 10% product. So now we're moving into, so that was 120 pounds of nitrogen back there. So very high rate, right? Very high, relatively high rate. Now as we move into, we are now in the 90 right now. We've changed a little bit, and you can there you might see some differences in how full that crop canopy is, basically how much biomass is there. And so, in part of this research, we have a sister trial located at the Mason Research Farm, close to campus, right? So we're using big data tools to try to predict varieties that have good nitrogen use efficiency. You would believe the number of biomass cuts. So we're really the the trait that we're after in the breeding program is the percent nitrogen composition. You heard Kurt talk about trying to get nitrogen into that flag leaf, right? Well, that was in the context of sulfur, but we are trying to get as much nitrogen into that crop as possible, right? And so part of that, we are using remote sensing technologies, hyperspectral imaging, right? So as humans, we see 3 bands, right? RGB, that's it. There are hundreds of wavelengths of light that we are not seeing right now, but our hyperspectral imaging tools can pick up on those, right? They're very specific signatures of nitrogen content, right? And so we are using this. This is our ground truth trial right now. And so we have some commercial varieties. Whitetail is marked in blue. If you see a blue flag, that's whitetail here. But we've got other varieties out here that are commercially available in the marketplace. So we've taken data streams from a couple sources, from the yen program, from the yen growers. They're taking these biomass cuts. We're getting percent nitrogen from there, and there's clear differentiation amongst these varieties. Whitetail being a variety that has very high nitrogen use efficiency, right? I don't think I'm going to tell you any of the low because I still want people to sell seed, right? There's still a lot of value in the certified, so I don't want to throw shade on any varieties at all here. But I want to highlight that there are some varieties that are better at sequestering the nitrogen in those plant tissues, right? And so it's really hard to get that trait. You have to come out here and you have to take all these biomass cuts in a replicated trial. We have 180 individual plots at 2 locations. It takes a small army to cover all that ground, right, and process all those samples, which we have. We have tremendous support from you all, and I want to note that this trial is sponsored by Mondelez, right? Mondelez, you've heard of Cheez-Its, right? You probably had some of those. Oreo cookies, right? That's Mondelez, right? They're very invested in the wheat value chain and maintaining a consistent product. And so we initially started down this road as a means to reduce carbon emissions, but it turned into we were going down the road of profitability, right? Looking at how these yields change, right? So what we are expecting to see from this work, and this is going to be some ongoing work, something that we are going to try to characterize, at least the MSU varieties that are entering the marketplace, but also identifying particular varieties that are commercially available that do have that differentiation of being more nitrogen use efficient, right? And so we have, this is essentially our proving ground for that, where we're using the big data tools, hyperspectral imaging, to try to detect nitrogen in plant tissues and advance them in the breeding program. So that's more of a breeding objective, but then those lines move into this proving ground right here. So we have these validation trials to be able to make a recommendation that this specific variety has this advantage, right? This profitability advantage of nitrogen use efficiency. So I want to slow down and ask any questions, comments from the group so far. I love a conversation about this. What are your thoughts on this, impressions so far? Well, I want to have at least 2 years of data on a line before making that recommendation, and so that's something that we are at least this is the first year of this, and so it's something that we plan to be doing long term, right? We have investments from industry in this. It's something that and from the Michigan wheat industry, but also from food companies as well. So it's something that'll be ongoing. Okay. Yeah. Yep. So all of these plots, we're going to bag all of them. We'll get somewhere from 8 to 12 pounds of grain off of these. We're going to dry them down, and they're going to be sent to the USDA Soft Wheat Quality Lab in Worcester, Ohio. We, as researchers, rely on USDA for some of these traits that are critical to the milling industry. Right? There's a whole there's a whole division within USDA that's focused on wheat quality, and so we have a USDA quality lab that will mill those samples, and they're going to do some proteomics work at Mondelez. So they're doing some advanced science there, again, some multi-omics types approaches, but they're going to look at the protein composition, right, that directly affects the functionality of those products. So they're going to see how these variations in nitrogen rates, right, and variety has a major effect on quality and protein composition, not necessarily quantity, but composition. We're gonna get to look at that interaction and find something that's ideal. What we don't want to do is change something on a massive scale on acreage that's going to affect the actual products, right? The quality of that grain and the ability of that grain to move through the value chain. It's very important. So we're going to be looking at that with Mondelez. We'll be shipping some samples off to them. So it's a very good collaboration we've got. we'll get the green light on being able to lower nitrogen rates. Now, and I want to highlight that we're still a year into this, right? So we've been using some existing data to identify candidates right now, some high and low NUE varieties. And so it's something we hope to see. The impact on this will be probably 4 to 6 years from now, right? Depending on buy-in from others, right? There's an element of, and we have to ground truth this. We have to validate this, right, to actually make that kind of a recommendation to a grower to reduce nitrogen rates and actually expect a similar year. Part of the profitability is not going to be maintaining yield. It will be getting a similar yield, maybe a little bit less, but with less investment. So it's going to come out in the numbers and the profitability end of things. And so you can think about this the way that they think about it in the spring wheat world, right? Where folks are focused on protein. You know, if you're a hard wheat grower, you got to hit 12, right? If you're in a spring, same with the hard red spring folks, is that there's a premium to protein, and so you have to factor in those other profitability elements that are not just yield, right? In some cases, the highest yielding line isn't the most profitable, right? So that's what we have to work through and have to demonstrate very reliably with the data that we have. Good. Other comments, questions? Let's take a look at the 60 pounds. See what you think about that. So we're right in the 90. Okay, fair enough. That's Jupiter there. Yep, yep. Yeah, let's use our border. So you can see we put a border in between the different treatments right here, so you might see some unevenness where the sprayer was on up to this point, off, and then switch back on there. But can you feel that difference as we walk into this 60-pound rate here? Now, but you will notice that not all varieties show the same kind of reduction. Now this is just me with my RGB eyes, right? We're not. I'm not tuned into the actual nitrogen here, but it's a breeder's eye only. But you can see that there's more yellow in here, right? There's less. The canopy is less closed, right? There's a lot more space in that canopy where the biomass should be, right? So we have this. We didn't have a 0 level treatment, but we had a 60-pound nitrogen level treatment. So we'll be able to see how those varieties perform at these different rates to be able to make that recommendation on reducing nitrogen rates for specific varieties. So overall, that's been one of our goals in the program, is to specifically tailor varieties to management plans, right? So that growers to maximize yield potential, right? Versus treating every variety the same, we're talking about customizing management approaches for specific varieties, right? Great. Other questions, comments? Absolutely, yeah.
One of the things that I wanted to ask you guys as growers is, what do you think about this concept? Are you willing to put less nitrogen on if you can get a similar yield? If we can develop new varieties that thrive on lower nitrogen inputs, or are you just going to say, no, another 30 units of N is worth the investment? What are your thoughts about this? Okay, so the comment was you don't think farmers want to save money. Well, yeah. So I'm sure that you would like to see some savings. So I guess what I'm wondering is, what do you think about? Would you be willing to lower your nitrogen rate if this provided you access to maybe a market that didn't exist before, providing it was economically feasible? So we'll calculate on all of these trials here. So within these bicycle flags, there's 2 of them up there, and then there's 2 of them right here, and then over here somewhere. This is all 1 rep. So there's, 20 varieties in here? Yep, so there's 20 varieties in here, and these are all have 60-pound nitrogen rate applied. We'll harvest it, we'll take the data, and then we will calculate the NUE, and then we will calculate a return on investment as well, and we'll report that to you. So if there's money to be made at a lower rate, is anybody willing to do it? Okay. All right. Okay. Yeah, so from here, go to field trials before we... Okay. Yep. So part of this is information for us to dictate kind of where do we take this, what's the next steps, what are the things we need to do concurrently with, developing varieties. That's Eric's charge here is to develop new varieties, but you know, we have to bring along with it, you know, what's the grower, you know, willingness and acceptance of this, and then I don't know if down the road, you know, higher NUE. I mean, food companies are going to be really interested in this because it's one way of lowering their carbon footprint, and it's not that hard to document this. You just take whatever the nitrogen savings are, do a formula and how many acres of each of these varieties we have out on the landscape, and boom, you got a number. It's pretty simple to do. So. Okay, so the question is, we're going to maintain the protein in the grain as well. That is one of the targets here. We've got to make sure that the 60-pound rate doesn't change, and that's why the proteomics work that Mondelez will do, and then we'll also get some of the other quality data from the lab in Worcester to ensure that we're not throwing the baby out with the bathwater, so to speak. We've got to make sure we can maintain that quality. But anything we can do, there's a lot of environmental programs out there to try to get people to reduce their nitrogen footprint. The Great Lakes Basin is one of the things where there's funding targeted at practices to reduce nutrient loading. And so there could be some opportunities for some other cost share programs as well with this. So I was just wanting to get a feel for what people thought about this concept. But we're, like Eric said, we're at the beginning. We got a long ways to go here yet, and we got to make sure the end product meets the standard, and then it's economically feasible. And then, like Dwight said, you know, we probably need to do some field scale trials. You know, we develop a couple new varieties, get them planted on the field, and let's do, you know, 3 nitrogen rates in that field and test it just to see what we got. So. Yeah, so it's also important to measure the soil, correct, to get an understanding of, you know, what is the actual uptake and where did it come from, too. That's correct. Because if we just use strictly nitrogen rates, we'd be omitting the, you know, what's the contribution from the soil. Yep, that's an important fact. That's part of the research protocol. So. So the question is, do we use any biological products to fix nitrogen? And is there anybody, is Kurt out here? I don't know if he's done some work with biologicals, I believe. I don't know where Kurt went, but okay. And Manny, I don't know if you've done any work on biologicals. We have some growers in our yen program that are using biologicals. I think there's a lot to learn yet about biologicals. The different soil types and how wet or dry the soil is impacts microbial activity and conversion processes in the soil to make nitrogen more available. So I think, you know, we're on the early end of that, or really knowing and being able to say, well, we need this biological product for this field in this year with the weather we have. So I don't. We haven't done any of that I'm aware of as of yet. Eric, are you aware of any?
No, there are a lot of folks working in that microbiome space to develop communities and very specific sets of microbes that will, you know, deliver a biological outcome, right? Like higher grain yield or more nitrogen fixation. But like that, it's complicated. The interplay from all of these. About genotype by environment interactions, now you're talking about genotype by microbe interactions and microbe by microbe interactions and all types of things that are very hard to quantify. But I got the microphone, but I want to make the comment about why we're applying nitrogen so early, and that you should not be applying once you get to flag leaf, leave it alone, because the source sink relationships changed early in the season. The sink is that biomass, right? That green tissue, but then after flag leaf, the sink becomes that developing spike, right? The developing spike tissues, and then the grain, right? And so we don't necessarily want, unless you're trying to, unless you want unless you want high protein, right? Unless you have a contract for high protein, you want most of that nitrogen going to biomass versus the actual grain itself, because you could, you know, you don't get paid for higher protein. Like we need stable protein levels in the region, right? And that's just something to keep an eye on. As our yields are going higher, we're potentially diluting the protein that's in that grain, though. So which a late application could help with some of that, but you have to pay for that, right? But just keep that in mind, is that you're going to get more bang for your nitrogen buck with that earlier application. It has to go out before flag leaf.
Are there any other questions about this NUE project that we've got going on here? None? Okay. Question in the back. Carry over into red wheat as in... Oh, we got...
Oh, absolutely, yeah. Yeah, we have both. Both out here, yeah, absolutely. It's balanced with red and white wheat.
Yeah, so definitely red and white, yes. Yes, definitely it applies to both. Okay, if there's no other questions, what we'll do is try to head back to the wagons, and then we're going to take you up here to the front of the field where we'll have our last stop, and then we'll head in for lunch. So try to walk in the same path you came. Try not to trample any more wheat than you have to.